one. What is the test for sulfate ion? Bhavya, Rohan, Anagha. Can anyone
Mom,
tell
it
me?
turns white.
White, but what we add? I want to ask what we add. If you are doing the confirmatory test, not H2SO4. I am asking the confirmatory test. Okay, hint, I am giving the silver nitrate test. It is a confirmatory test for both chloride, chloride and iodide.
When we add barium fluoride, then a white current precipitate is formed.
Okay, you are talking is correct. But the actual is that what we are adding is original solution plus dilute HCl plus barium chloride, if you remember. Okay.
Yes, ma'am.
Okay. Now, when we are doing the silver nitrate test, what we again take is original solution plus AgNO3, and what we are adding further. What is the acid we are adding? Generally, we are adding the acid. Which acid I am adding? Dilute HNO3. Now, you are noting something common, that we are adding nitrate. If I am adding AgNO3, silver, main reagent is silver nitrate, but I am adding little amount of HNO3. It means nitrate ion is common. Here, main reagent is chloride ions, but I am adding is Cl. Similarly, when we are going to do the cations, I think we have done a few cations, but when we are doing the cations, like generally what we are adding is NH4Cl plus NH4OH. It means we are adding ammonium ion as common. So it means that there is certain role of common ion. There is certain role of common ion. Silver nitrate, AgN, barium chloride, all these are weak electrolytes. Okay, so what we are studying today is the common ion effect on equilibrium of weak electrolyte. Since we have not done these few of the practicals further on cations, we have not done much. So generally we relate it to the cations. So I won't be able to relate, but let us understand what is common ion effect. Okay. So cations I am just leaving for the time being. In 12th we will be explaining to you during the practicals. Hopefully everything will be okay in class 12. The common ion effect on the equilibrium of weak electrolyte. Okay, now this I am explaining with the help of a simple example. Then I will be taking the question based on same. Let me take the question based on same. Let me. चलो ऐसे पहले समझा देते. If I am taking is acetic acid, and we know that at equilibrium it converts into acetate ions and H plus ion. It is a weak electrolyte. So in the case of a weak electrolyte, it is not completely dissociated in the aqueous solution. All of us know. Now suppose what we know that initially, if it is C moles, Rohit, can you tell me further what will be the concentration of acetate ions and H plus ions initially? Rohit, I can see your name. Sahil. Rohit. Now, can you tell me, Sahil or Rohit, who has said yes, ma'am? Now, can you tell me what we have studied yesterday? Initial concentration in C moles, then.
मैम मैं तो पूछ रहा था कि रोहित नाम का कोई है भी हमारी क्लास में.
एक मिनट बी में सॉरी एक मिनट नहीं मैंने रोहित गलत देखा है. इट्स आई वाज आस्किंग ओके तलत. I was asking the question, students of 12th B, so I am not remembering them. Okay, Talat.
Ma'am, it will be 0.
It will be 0, 0. Okay, what will be final? How we take?
Ma'am, your video is blurred.
Is it blur for everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
ma'am.
Okay, let me join again. Is it okay now?
Yes, ma'am. Yes, ma'am.
What will be final? I asked Talat how to answer it. What will be the final?
It will be C minus C alpha.
Yes, good. And what about this?
Ma'am, C alpha, C alpha.
Okay. Now what is Kc for the reaction? How to write Kc?
Ma'am, it will be C alpha square upon C minus C alpha.
Yes. Just C, what you got, C minus C alpha. So C, one of the C will cancel to C alpha square upon 1 minus alpha. Is it okay? This C I will take common, so it will become C 1 minus alpha. So C will get cancelled. So C alpha square upon 1 minus alpha. And generally, what I have told you that alpha is very small, generally, as compared to 1. So it means 1 minus alpha is almost equal to 1. Is it okay? So this is Kc. Kc is equal to C alpha square, generally, unless value of Kc is very high. Okay. Now suppose we add, what we are studying is the effect of common ion. So if a reaction is at equilibrium, we have calculated the Kc for this. And I am simplifying it. I am simplifying to Kc as C alpha square. Otherwise, it will be difficult for you to understand. Now, suppose we add 0.1 molar HCl. What will be the effect on equilibrium? So if to the above, okay, so if I am adding is 0.1 molar HCl, what will be the effect of HCl on the equilibrium of acetic acid? Now, HCl is a strong electrolyte or a weak electrolyte?
Strong electrolyte.
HCl is a strong electrolyte. It means that HCl will be completely dissociated to form H plus ions and Cl minus ions. Okay, so if it is completely dissociated to form ions, let's wait. So HCl will be completely dissociated to form H plus and Cl minus ions because HCl is a strong electrolyte. Now my question is, if initially if I am adding is 0.1 molar, I have added 0.1 molar. So it means initial it is 0.0. What will be the final amount of HCl? What will be the final amount of HCl?
0.
0. Because the strong electrolyte. So I am getting is 0.1 mole of H plus and 0.1 mole of Cl minus. Okay. Now in the question, what I am taking is acetic acid and I am adding HCl to it. So what is the effect of H plus ions or HCl on the acetic acid? Now, concentration of H plus ions increases, yes or no? So if I am taking is acetic acid, ठीक है, तो इसकी concentration थी C minus C alpha. This I am
Ma'am, your
putting down.
board is little blurred.
Blurred है. Again for everyone.
ठीक है
Ma'am, it's
ठीक है
fine.
मैम
It's fine. Clear.
Okay.
It's a little blurry.
But you because if it is clear to even few of the students, it means connection is okay. So you check your own. Sometimes it happens. Otherwise, I have to switch off and again switch on. So if it is C minus C alpha, this I am again noting the same. If it is C minus C alpha and it was C alpha and again it was C alpha. Now what will be the new concentration of H plus ions? New concentration after adding H plus.
Ma'am, it will be C alpha plus 0.1.
Yes. New concentration after adding HCl. Now HCl is giving us 0.1 mole of H plus ions. So it means new concentration of H plus will be C alpha plus 0.1. Acetate ions will remain same. So we are increasing the concentration of H plus ion. So what the Lee-Chatelier principle says now? What happens according to Lee-Chatter's principle? If I am disturbing the equilibrium, what happens?
It will try to
Backward direction.
minimize the effect.
Yes. If we increase concentration of H plus ion, I am writing each and every line so that topic is clear to you. If we increase concentration of products, reaction will go in which direction?
Backwards.
Reaction will go in backward direction. Is it okay? The reaction will now go in backward direction. Is the point clear? So now the new value will be changed because now the reaction is going in backward direction. So this point you have to keep in mind. And again, we can calculate the equilibrium constant. So further, I will be taking in the form of a numerical only. Okay. I hope this topic is clear. What we are going to do, we are taking is a weak electrolyte. We are adding a strong electrolyte having the common ion. Then we are studying what will be the direction of the reaction and how to calculate it. Okay. So because if I am not taking a numerical, then I have to explain each and everything again. So it's better now I am let me take a numerical. Okay, let me take the first NCERT sort example. Or let me take, okay. I am taking this question, just write down. The ionization, I am taking a different question, NCERT question, you try to solve yourself. The example of NCERT example 7.24. Please try to solve on your own. I am taking a similar question. Now my question is ionization constant or simply Ka for propionic acid. Ka for propionic acid is 1.32 into 10 की power minus 5. Calculate degree of dissociation if the solution is 0.05 molar. 0.05 molar. What will be the degree of dissociation? What will be the degree of dissociation if the solution is? What will be the degree of the solution ionization if the solution is 0.01 molar in HCl also? Okay, this is my question. Now, what is propionic acid? Propionic acid is same as, what is propionic acid or propionic acid? What is the formula? Can anyone? Yes, what is the formula of propionic acid? Siddharth, Jan, what is the formula of propionic?
Ma'am, it will be, ma'am, just a second, CH3, CH3, CH2, COOH.
Yes, and by chance you are not knowing the formula of propionic acid, तो क्या करो? Simply इसको HA लिख देना. HA means any acid. क्या question हो जाएगा at least. ठीक है? Now propionic acid will dissociate to form CH3CO minus, sorry, CH3 CH2CO minus and H plus. So this is a general trick I was telling you. If you don't know the formula in any case, so just write HA और ऊपर लिख दो propionic acid. तो HA भी अगर आप लिख देते तो it will give us A minus and H plus. Question आपका हो जाता. ठीक है? Now it is given that initial C alpha 0 0 Initial C 0 0, final C minus C alpha, C alpha, C alpha. This now you should be very much thorough with it. Okay, now what is Ka? C alpha, C alpha. Please try to find out in the question only. So C and C will cancel to C alpha square upon 1 minus alpha, which is equal to C alpha square. Because 1 minus alpha is almost same as 1. Alpha is very, very small. Power is 10 raised to power minus 5. Even if it is 10 raised to power minus 4, you can neglect it. No issue. Okay? So Ka is equal to C alpha square. Okay. Now, can you calculate what is alpha in this case? Can you solve it? What is alpha? Can you solve the value of alpha?
अब 1.6 into 10 की power minus 2 आ रहा है.
Okay. 1 point Google search. ये क्या है?
किया है मैम.
Into alpha square. So alpha square is equal to 1.32 into 10 की power minus 5. This I am writing as 5 into 10 की power minus 2. तो 5 से divide करेंगे तो 5 6 the 5 to the 12 32 6.4. Now to find out square root, we know it should be in a even number. So I can write is 2.64 into 10 की power minus 2. या आप इसको ऐसे भी कर सकते थे 264. ठीक है, तो it's up to you. You could have written it as 264 into 10 की power minus 4. That was also correct. Now what is 16 square? 256. So it is very much closer to 6. So it will be 16 into 16.1 या 2 ले लो into 10 की power minus 2 आ जाएगा square root. Minus 2 or 0.16. Is it okay? This is my alpha. 0.16 you could have also written. That's not an issue. So now what we have calculated is the value of alpha. Now further what we have to do, now we are studying the effect of HCl. Okay. Now HCl that I am adding. So this is the first part. This question suppose is of 3 marks. Generally 4 marks से कम नहीं होना चाहिए. Okay, if it is of 3 marks, so half mark will be for writing this. Okay, then half mark will be for substituting the values and 1 mark will be for finding out alpha. So 2 marks will be over till here. So this proportion can be, this numerical can be of 2 marks. If ये question आपको separately भी आ सकता था ना? This question could have come separately also.
मैम उसमें थोड़ी 10 की गलती नहीं है?
Let me check.
Yes, मैम लग रहा है.
हम 1.32 को 5 से डिवाइड करेंगे तो 0.264 आएगा ना?
0.264 into 10 की power minus 3.
यस मैम. तो मैम फिर
अच्छा, फिर मैंने इसको कर दिया 2.64.
अब मैम into 10 की power minus 4.
यस मैम. तो 10 की पावर minus 2 into 1.6 आएगा. 1.6 होगा 16 point only.
वो बात सारी तरह दूसरा तो यहाँ पे पावर में चेंज करना बोलते हैं. ठीक है. This is what you are saying?
Yes, ma'am.
1.62 into 10 की power minus 2. Okay, so this question, if it is individual question till here, if a common and effect is not given, then it may be of 3 marks. If it is a form of this, then again it will be of 3 marks. So it depends upon the format of the question. Now in the question, what we are adding is 0.01 molar HCl. Then what will happen? If we are add 0.1 molar HCl, then what will be the new concentration at equilibrium? Then how to write it? Start solving it and first write yourself.
Ma'am, it will be ma'am, C alpha plus 0.1.
Okay, so amount of H plus ions will be 0.1 plus C alpha. Yes or no? Initially it was C alpha. Now when we are adding 0.1 molar HCl, the amount of H plus ion will be 0.1 plus C alpha. Now what about this one, acetic acid? Propionic acid. Suppose I am taking at equilibrium. Now at equilibrium, amount of H plus ions will be this plus C alpha, this will be C alpha. What about this? Since we are knowing that the reaction is going in backward direction, what should I take in this place?
C.
Only C. See, generally what we are taking is C minus
C plus 0.1.
Generally what we are taking is C minus C alpha. But we always know that C और अगर backward भी चला गया थोड़ा सा और change हो जाएगा. But we know that this term is negligible. We all know that this term is negligible. We are doing that 1 minus alpha is almost equal to 1. Yes or no?
Yes.
So this term is negligible. So instead of making it complicated, just try to neglect this term here because we can see that alpha is very small. We can see the value of alpha. Degree
Yes,
of
ma'am.
dissociation from 1 mole, if I am taking, it is only 1.62 into 10 raised to power minus 2. So it is very, very less. So better है you neglect it here. So now what? Because this question, second part is not lengthier part. You have to do it in short. Because generally no one is giving you numerical in 5 marks. Okay. Even if it is coming for 5 marks, then 3 marks to first part ki ho jayegi, so only 2 marks are left. So we should not do this in too lengthy process. So I am telling a shortcut method. So this is negligible. So instead of this, I can write it simply C, because here also we were taking C minus C alpha and then we were neglecting it. So we were writing C 1 minus alpha and 1 minus alpha was equal to 1. So this I am taking as C only. There won't be much effect. So what is new equilibrium constant now? My question was to calculate the what will be the degree of ionization. So if I am, instead of alpha, if I am taking the degree of ionization as alpha dash, okay, I am taking the degree of ionization as alpha dash, because when we are adding is H plus, the reaction is going in backward direction. So agar pehle degree of dissociation alpha thi, now it is alpha dash. And alpha dash is even becoming smaller. Why it is becoming smaller?
क्योंकि रिएक्शन बैकवर्ड्स जा रहा है.
Backward में चला गया, तो alpha dash जो है, it is even smaller. So if new dissociation constant is alpha dash, so alpha dash is even smaller. So we can neglect it. So now what is new? Now what is K? K is equal to C alpha dash 0.1 plus C alpha dash upon C. Is it okay? So this is how we are simplifying the equation. Now what is the value of K? K value remains same. Value of K is always same. Okay. So K की value was 1.32 into 10 की power minus 5. C and C will get cancelled, all of you know. Is equal to alpha dash 0.1 plus C alpha dash. Is it okay? Now, see, all these methods, the calculations are basing on neglecting. Like here, I was neglecting alpha as compared to 1, so 1 minus alpha is equal to 1. Here again, I was neglecting this term. Okay, so C 1 minus alpha dash, so it was again equal to C. So alpha dash, I am always neglecting. Just wait for a minute. Okay. Is it quite clear? Now what we are doing it now, as I have told you now, C we have told that C alpha dash. I have taken alpha dash is very small. Is very small. Even smaller than alpha. So it means जब अगर मैंने 1 minus alpha को 1 ले लिया, तो अगर मैं 1 plus alpha भी लेती तो उसको भी 1 लेनी थी. Because alpha I am neglecting. Now what I am saying is that alpha dash is very much smaller. So it means that 0.1 plus C alpha dash. Concentration, what is the concentration? What was the concentration of propionic acid? What was the value of C? 0.05.
0.05.
0.1 plus C alpha dash. If I am taking it is 0.1 plus 0.05 into alpha dash. It means alpha और भी smaller हो गया. I am multiplying it by 5 into 10 की power minus 2. So it means we can neglect this term. I can neglect this term again. We don't want to make a quadratic equation, so I will neglect this term. Okay.
Can you explain, please?
Okay. I am explaining again. See, that's why I am writing each and every step. So this was we have got. यहाँ तक समझ आ गया? Any doubt till here?
No, ma'am.
No. Now what I am saying is that alpha dash is very small. I have told you because in this reaction, when we are adding is more amount of products, the reaction is going in backward direction. So alpha dash is even smaller than alpha. First thing, this point should be remembered. Then we have formed the equation. Now again, I am saying that alpha dash is very small. Now I have taken this approximation earlier. 1 minus alpha is almost equal to 1 because alpha is very small. So if I am taking 1 plus alpha, again alpha is very small, so it should be equal to 1. Now this equation was now I am trying to solve this one. How to simplify this one? So what I am writing is that this point 0.1 plus C alpha dash. Now if I am putting the value here, okay. So I can first I am explaining, then I will explain with the help of again the equation. If I am taking only this value 0.1 plus C alpha dash, so it will be equal to 0.1 plus C. Iski the concentration, C was the concentration of propionic acid. We are taking this question CH3. The concentration of this acid was C, and the value of this is given as 0.05. Now suppose alpha dash is equal to 1.4 into 10 की power minus 2. Now, अगर C से मैं इसको multiply कर दूंगी तो it means 0.05 alpha will be equal to 5 into 10 की power minus 2 into 1.4 into 10 की power minus 2. So answer will be 10 की power minus 4. It means it is very small. It is even becoming more smaller. So it means that we can also neglect this term, and instead of this I can write is simply 0.1. Instead of this term I can write is simply 0.1. Okay, so wherever we are taking alpha or alpha dash in comparison to certain other term, we are neglecting it. 1 के comparison में 1 plus है या 1 minus है, 0.1 है, 0.01 है, whatever it is, I am neglecting alpha dash. So it means that now this equation, okay, let me take to 1. Equation 1 can be written as equation 1 can be written as 1.32 into 10 की power minus 5 is equal to alpha dash. This was the equation. Now C alpha dash is very small. It means I can neglect it. So it means 1.3 into 10 की power minus 5 is equal to 0.1 into alpha dash. So what is new alpha dash? 1.32 into 10 की power minus 5 upon 0.1. So it will be 1.32 into 10 की power minus 1, so 10 की power minus 4. Is it okay? So if you are doing in the exam, I have explained each and every line to you, but you can do it very short. You can add C minus C alpha dash 0.1 plus this. Then you can form a quadratic equation, neglect it. और actually में अगर आप देखोगे तो आपका फॉर्मूला बहुत ही सिंपल है. ये आपका था KA. ये आगे आपका 0.1 में जो भी आपने concentration ऐड की थी into alpha dash. This is the formula. So new alpha dash is equal to Ka upon the concentration added. First concentration is C. अब मैंने जो ऐड की इसको सपोज मैं C1 ले लेती हूँ या C2 ले लेती हूँ, तो आपने जो न्यू कॉन्सेंट्रेशन जिसके भी ऐड किया है, आपने HCl का 0.1 ऐड किया, तो आई एम टेकिंग सिंपली दिस फॉर्मूला. तो अगर आपका MCQ है 1 मार्कर क्वेश्चन है, यू कैन सिंपली राइट लाइक दिस in this particular case. But again, it's better if you write like this. See, if you have to do in exam, let me tell. Okay, I will be taking one more question. Is it okay?
Yes, ma'am.
I am taking another question and we will do that fast. So tomorrow I will be taking one more period. Tomorrow is Saturday, so tomorrow I will be finishing the syllabus. सोचा था लेकिन मेरे से जल्दबाजी नहीं हुई. यही क्वेश्चन कर ले, लो बताओ आगे कराओ. Whatever you suggest.
मैम कल तो ऑफ है ना वैसे?
क्यों? Tomorrow is first Saturday. It's not off. Okay.
मैम
आगे करा दे, ठीक है. Just do problem number 7.24. Okay. Now next topic is, now there are very small topic. One of them is the factors affecting the acid strength. This I have not taken. Polybasic acids, you know, जैसे HCl है. HCl gives 1 H plus ion. So HCl which gives 1 H plus ion is a monobasic acid. Sulfuric acid. One of the sulfuric acid breaks down to form 2 H plus ions and sulfate ions. So it is a dibasic. Dibasic means 2 H plus. And if I am taking is phosphoric acid, what will be it? How many H plus ions?
3.
4.
4 cases, 3 H plus. H3PO4. So 3 H plus and PO4 3 minus. So it is a tribasic acid. For acids, we do write the basicity. Monobasic acid, dibasic acid, tribasic acid. Okay. Next is factors affecting acid strength. This again we have done in the S block, but let me take in short. Factors affecting acid strength. Now first factor is that with the acid strength, what we are taking in the form of HA. As the size of A increases, so H bond A becomes weaker and acidity increases. Now what does it mean? If I am taking is HF, HCl, HBr and HF, which is the larger in size, which is more acidic, or which atom is larger in size out of HF, HCl,
Iodine.
HBr? Iodine. So it means that due to the larger size of iodine, एक्चुअली इसके न्यूमेरिकल्स जितने भी कराओ ना उसमें टाइम लग जाता था. Due to larger size of iodine, H bond I is weak. Okay, so it means that it is more acidic. So HI is a stronger acid as compared to HBr. HF is a weakest acid. Now, second thing, if we are taking suppose like this we have got nitrogen, oxygen, fluorine. Now, if I am taking is ammonia, H2O and HF, we know that ammonia is a base. So HF is a stronger acid. Why? Can anyone explain why ammonia is a base but HF is a stronger acid? Yes.
Ma'am, maybe because fluorine is more negative than nitrogen.
So with the increase in electronegativity, fluorine is strong, more electronegativity. Fluorine is the most electronegative element in the periodic table. So with increase in electronegativity, H bond A becomes weaker. Okay, H bond A becomes weaker and acidic character increases. We know that most electronegative element is HF, then it is H2O, and then it is ammonia. Similarly, if I am taking is H2S and HCl, chlorine is more electronegative than sulfur, and so it is more acidic. So we have to see both the factors. If you are moving down the group, like if I am taking water, H2S, then we are moving down the group. So H2S is more acidic than water. But if you are moving along a period, so along a period, acidic character again increases, and down a group it also increases. Along a period it increases. Why? Because the electronegativity difference increases. Down the group it also increases, because with the increase in size the bond becomes weaker. So these are the two factors on which the acidic strength depends. Okay, so these were the little small topics which were left. Now this topic number 7.11.9, hydrolysis of salts and the pH. This topic is deleted. 7.11.9, this topic is deleted. Yes.
Which topic?
Hydrolysis of salt and the pH. Complete topic is hydrolysis of salts and the pH. Topic number 7.11.9 of the NCERT. This has been deleted. Okay. Now this topic also we won't be doing. Topic number 7.13.2. The topics that we are not going to do, that I am telling you, because otherwise it becomes too difficult for you. The 7.13.2. Okay, 7.13.2. These two topics are deleted. Okay, so now we are left with the topic, small topic of buffer solution and solubility product and iron. Starting with the buffer solution, I am telling today, it's a definition only, nothing there. We are not going to do any explanation for this because it is not in the syllabus. So buffer solutions are those which register change. Just remember the definition, which register change in their pH on adding a small amount. It should not be added in excess. On adding a small amount of an acid or a base. A buffer solution is the one which registers change in their pH on addition of a small amount of an acid or a base. So these type of solutions are called buffer solution. And for bio students, it's very important because we know that our stomach, what is the pH of our stomach, acidic or basic?
Acidic.
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 The stomach is acidic. Now, whenever we eat something, when kuch bhi hum le rahe, it can be acidic or basic. Suppose I am using baking soda in the food. So will the pH of my stomach change? pH of the stomach is acidic. Suppose I am taking a food which is slightly basic. If I am taking a food which is having baking soda or ENO, will the pH of the stomach change drastically?
No, ma'am.
No.
No, ma'am.
Similarly, if I am taking
Ma'am, it will neutralize her.
Yes, it will neutralize and pH में minor change होगा. एक pH की range होती है. Suppose we are taking the pH of the blood. The range is I think 7.36 to 7.42. Now blood is slightly basic. Now if I am taking tomato, if I am taking orange, will the pH of the blood change? No, it will remain in this range. So these are the two examples of natural buffer. That is the blood as well as the stomach. Juices in the stomach. Okay, so but if I am taking chemically, there are two types of buffer. One of them is an acidic buffer. Example of acidic buffer is acetic acid and its salt. Weak acid and its salt. Salt is sodium acetate. Basic buffer is a weak base. Weak base is NH4OH and its salt. Okay, weak base and its salt. Weak acid and its salt. So that's the topic only. We don't have to do anything much in this topic. Just remember What is the buffer solution? Give one example of acidic and basic buffer. Details are not in your book and they are not in your syllabus. Okay, so we are left with solubility product. That's again an easy topic. So that we are going to do tomorrow. Tomorrow, which period we are having? I am noting down the attendance also. Just wait. No one should leave. Yes, which period we are having tomorrow? 11th A, 11th B. I think the
Ma'am, we have 4th period, ma'am.
11th B may be same period.
No, ma'am, it's the post period.
Okay, I will see.
Ma'am, we have 4th period, ma'am. 11:55 to 12:45.
Yeah, I will see if something can be managed. Okay.
Ma'am, please show the board.
1 minute. Are you able to see?
Yes, ma'am.
Ma'am, our school's gonna open for exams.
But it will be decided by the government. But obviously, as you know, the schools may be reopening even on Monday. They can reopen even on Monday. As the government decides.
And what is opening on Monday?
I am saying they were asking the schools reopening for exams. I said it's the decision of the government, but maybe as it's coming in the news, maybe the school reopens on Monday. Maybe. Whatever is the decision of the government and the DDMA meeting.
Ma'am, yes,
Ma'am,
ma'am. Actually, today is the DDMA meeting, ma'am.
Today is the DDMA meeting. So it will be decided today. By the evening, you will be
Ma'am,
knowing.
can you tell acidic and basic buffer?
Yes, acidic buffer consists of a weak acid and its salt. It means its pH will be less than 7. And basic buffer means a weak base and its salt, so pH is more than 7. How they act, this we are not going to do. This is not beyond our scope.
Repeat the topic which we cannot know, ma'am. You just said.
Pardon?
Ma'am, can you repeat the topic? You just said it is not coming in the syllabus.
Okay, one of the topic is hydrolysis of salts and their pH. Okay, let me tell the topic number from the NCERT. Just wait. I have closed my NCERT. I think it's 7. 1 minute.
7.9.
7.11.9, I think.
Yes, ma'am.
It is 7.11.9. Next topic is 7.13.2. That is common ion effect on solubility of salts. These won't be coming on in the exam. Okay, common ion effect on solubility of salts. These two topics are deleted.
Yeah, ma'am.
Okay, thank you.
Ma'am?
Yes.
Ma'am, if the schools reopen on Monday, then we'll be having a practical.
It will be given by the school authorities. Just wait for the official information, whatever information we are getting.
Okay.
Ma'am, attendance.
All the
Attendance I have taken.
Ma'am, could you resend all the deleted topics?
But better hai you see the CBSE syllabus. I won't be sending you a list of the related topics, but I will be sending you the topics that are there.
Okay, ma'am, that will do.
Okay, I will be sending it in the group. Okay.
Thank you,
Ma'am,
ma'am.
attendance kab?
Attendance I have taken already. I have taken downloaded the attendance. Okay.
Okay.
Thank you, ma'am.
Okay. So tomorrow
Okay,
again last class. Syllabus is almost over only. Just winding up. Okay.
Thank you, ma'am.
Welcome.